In this EzEd video lecture, we are going to learn Introduction to Data Files, defining and opening a file, closing a file, input-output operations on files, fprintf and fscanf functions, error handling during I/O operations, random access to files, command-line arguments. Till now we have studied printf and scanf functions in C to write and read small amount of data through the terminal. But often we are needed to handle large data which cannot be read through the terminal, and so we need to use files for handling large data. Sometimes those files contain information about something we are writing in a word processor, for example, or at times those files contain other information like results of calculations, and sometimes those files contain results of measurements we took in a laboratory or out in the field. Therefore, files are required for permanent storage of data and processing of data. A file is a place on the disk where a group of related data is stored. C supports a number of functions that have the ability to perform the basic file operations like naming a file, opening a file, reading a file, writing a file, closing a file. Moving on, defining and opening a file. When we want to store data in the secondary memory on the disk, we need to specify certain things to the operating system. They include file name, data structure, purpose. File name is a string of characters that make up a valid file name for operating system. It consists of two parts. One is the primary file name, followed by the optional period and extension. Look at the examples here. A data structure of a file is defined as a file in the standard input-output library definitions. Therefore, all the files should be declared as type file before they are used. File is a defined data type. When we open a file, we must specify what we want to do with the file. For example, we may want to write data or read data. The general format for reading and declaring a file is this. First statement declares fp as a pointer to the data type file. As stated earlier, file is a structure that is defined in the I/O library. Second statement opens the file named file name and assigns an identifier to the file type pointer fp. This pointer contains all the information about the file, is subsequently used as a communication link between the system and the program. The second statement also specifies the purpose of opening a file. The mode can be one of the following. Open the file for reading. Open the file for writing. Open the file for appending data to it. When opening a file, one of the following things might happen. 1. When opened in writing mode, the file with the specified file name is created if the file does not exist. The contents are deleted if the file already exists. 2. When the file is opened in appending mode, the already existing file is opened with the contents saved. A file with specified file name is created if the file does not exist. Third, if the mode is reading and if it already exists, then the file is opened with contents safe, otherwise an error occurs. In this example, the file data is opened for reading and results is open for writing. Next, we learn closing a file. A file must be closed as soon as all the operations on it have been completed. This ensures that all the underlying information associated with the file are flushed out from the buffers and all links to the file are broken. In case where there is a limit on the number of files which can be opened, closing an unwanted file might help to open the required files. Another instance where we might want to close file when we want to reopen the same file in different mode. The I/O library supports a function to do this for us. It takes this form. This will close the file associated with the file pointer, file_pointer. This program opens two files and closes them after using them. Once the file is closed, its file pointer can be reused for another file. All the files are closed automatically as soon as a program terminates. Moving on to input-output operations on files. Once a file is open, reading out or writing to it is done using the standard I/O routines. Now let's learn getC and putC functions. The simplest of file I/O functions are getC and putC. They are analogs to getChar and putChar functions and handle one character at a time. Assume that a file is opened in W mode and file pointer fp1, then the statement writes the character contained in the character variable C to the file associated with file pointer fp1. Similarly, getC is used to read a character from a file that has been opened in read mode. For example, would read a character from the file whose file pointer is fp2. The file pointer moves by one character position for every operation of getC and putC. The getC will return an end of file marker EOF when end of file has been reached. Therefore, reading should be terminated when EOF is encountered.
Hey, it's time to concentrate now.
Write a program to read data from the keyboard and write it to a file, and also read the same data and display it on the screen. We start by declaring the main function. The file pointer fp is declared as a pointer of type file and the variable ch of type character. Fopen function is used to open a file named file in writing mode, and the pointer fp is made to point to this file. Then we ask the user to enter the data to be stored in the file. GetChar function is used to scan in one character at a time. This will be repeated using a while loop till the end of the file character is scanned. The scanned character is placed in the file using the file pointer, after which we close the file. Again, we use a loop to print the characters and print them using printf function. Then we close the file using fclose function. Next, we learn the getW and putW functions. They are integer-oriented functions. They are very similar to getC and putC and are used to read and write integer values. These are useful when we have to deal with integer data. This is their general form. Now let's write a program to illustrate the use of getW and putW functions. We start by declaring the main function, followed by the file pointer variables f1, f2 and f3, along with I and number. Then we ask the user to enter the text inside the file, after which we open the file data pointed by f1 in writing mode. We use a for loop to scan in the numbers till the user enters positive numbers. As soon as the user enters a negative number, the loop's execution breaks. Each positive number entered is placed in the file using the putW function. The file is closed then. Then file data is opened again in reading mode, while odd is opened in writing mode, which is pointed by f2 and f3 points to file named even which is opened in writing mode. While loop is used to get each number from f1 till the end of file is reached. Then we apply the logic to sort even and odd numbers. If the number is divisible by 2, then it's an even number and placed in the even file pointed by f3. Else the number is placed in the odd file pointed by f2. After which we close all the three files. Then we open the even and odd files in reading mode. While loop is used here to get each number from odd file to the end of file is reached, and the number is printed using the printf function. Similarly again, while loop is used here to get each number from even file till the end of file is reached, and the number is printed using the printf function. Lastly, we close both the open files and end the program.
Seriously, pay attention. This is important.
Moving on to fprintf and fscanf functions. We have seen functions that can handle only one character at a time. Most compilers have fprintf and fscanf functions which allow to handle mixed data. The functions fprintf and fscanf perform functions similar to printf and scanf functions. The first argument of these functions is the file pointer followed by the control string. The general format of fprintf function is where fp is the file pointer, control string contains the output specification, and list consists of the list of variables or constants. Here in this example, name is an array variable of type char and age is an int variable. The general format of fscanf is this will cause reading of the items in the list from the file specified by fp according to the specification of the control string. Fprintf and fscanf returns a number of items successfully read. When the EOF is reached, it returns the value of EOF. Let's write a program to illustrate the use of fprintf and fscanf functions. We start by declaring the main function and the file pointer fp, followed by the variable id. of type int, while fname and lname are declared as arrays of character type, after which we open the file in append mode. This means that the initial file position of reading is at the beginning of the file, but output is always appended to the end of the file. The ID, fname, and lname are read from the file. Here it prints all the elements that are registered in the file till the end of the file is reached. Now if we want to place in the end of the file a new element, example for John Reno, then this is done using fprintf function. Then we close the file and end the program. If we open the file, we find the new data being appended to the new file. Now we learn error handling during I/O operations. It is possible that an error might occur in a file during I/O operations. The possible errors are trying to read beyond end of file marker, device overflow, trying to use a file that has not been opened, attempting to write protected file. If we fail to check such errors, the program will behave abnormally when errors occur. An unchecked error may result into premature termination of the program or incorrect output. C provides two status inquiry library functions, namely feof and ferror. This is the general form for feof function, used to determine if the end of the file specified has been reached. When a file is being read sequentially, one line or one piece of data at a time, by means of a loop, say, this is the function you check every iteration to see if the end of the file has come. It returns non-zero true if the end of the file has been reached, 0 false otherwise. Write a program to illustrate the use of feof file. We start by declaring the main function and the character array for the variable buffer. Also, we declare a file pointer named myFile. Then we open a file named sum in reading mode and make the pointer myFile point to it. While loop is used to check if end of file has been reached or not, till which the string is read from the file and copied to the buffer and the buffer is printed, after which we close the file and end the program. The ferror function reports the status of the file indicated. It also takes the file pointer as its argument and returns a non-zero integer in an error has been detected up to that point during processing. It returns 0 otherwise. This statement checks if any error occurs and notifies the user if error occurs. We know that whenever a file is opened using fopen function, a file pointer is returned. If the file cannot be opened for some reason, then the function returns a null pointer. This facility can be used to test whether a file has been opened or not. Write a program to illustrate error handling in a file operations. We start by declaring the main function followed by the file pointers and another pointer of type character along with other variables. We open the file test, which is pointed by fp1 in writing mode, and place integers 1 to 10 in it using putw, after which we close the file. We ask the user to enter the file name and save it in the variable file name. If the pointer returns a null pointer, then the file cannot be opened, and so the user is notified and asked to enter the file name again. Else, a for loop is used to get each number from the file and display it till the end of the file is reached, which is checked using the feof function, after which we close the file and end the program. Now we learn random access to files. We have studied to access data sequentially using for reading and writing it, but at times we are interested in only a particular part of the file and not the entire file. This can be achieved with the help of the functions fseek, ftell, and rewind available in the I/O library. ftell takes a file pointer as a parameter and returns a number of type long which corresponds to the current position of the pointer. The general form is n gives the relative offset in bytes to the current position. It means that n bytes have already been read. Rewind takes the file pointer as parameter and resets the position to the start of the file. This statement would assign 0 to n because the file position has set to the start of the file by rewind. This function enables us to read the file more than once without opening and closing the file again and again. Fseek function is used to move the file position to a desired location within the file. It takes the following form. File_ptr is a pointer to the concerned file. Offset is a number of variable of type long. Position is an integer number. Offset here specifies the number of positions to be moved from the location specified by position. The position can take one of the following three values. The offset may be positive, meaning move forward, or negative, meaning move backwards. Have a look at the examples. Seek to the 100th byte of the file. Seek backwards 30 bytes from the current position. Seek to the 10th byte before the end of file. Seek to the beginning of the file. Seek to the beginning of the file. When the fseek operation is successful, the file pointer returns as 0. Otherwise, if we attempt to move the file pointer beyond the file boundaries, an error occurs and fseek returns -1. Write the program to illustrate the use of fseek function. We start by declaring the main function and followed by the file pointer. Then we open the file in writing mode, which we put the test hello word in the file. Fseek function is used to seek the 6th byte of the file. This line places the word India in the current seek position, after which we end the file.
Seriously, pay attention. This is important.
Now let's study command line arguments in C. In C, it is possible to accept command line arguments. To use command line arguments in your program, you must first understand the full declaration of the main function, which previously has accepted no arguments. In fact, main can actually accept two arguments. One argument is number of command line arguments, which is of integer type, and the other argument is a full list of all the command line arguments declared as an array. The full declaration of main looks like this. The integer argc is the argument count. It is the number of arguments passed into the program from the command line, including the name of the program. The array of character pointers is the listing of all the arguments. Argv is the name of the program, or an empty string if the name is not available. Let's write a C program that explains the use of argc and argv. We declare a main function with arguments argc and argv. We input the program name and the file name. argv0 is the name of the C program. argv1 is the file name. The program first checks to ensure the user has added two arguments. If not, then error is printed. The program then checks to see if the file is valid by trying to open it. This is a standard operation, and if it results in the file being open, then the return value of fopen operation will be valid file pointer. After that, we print the file contents till the end of file is reached. We then end our main function. The output of this program will print all the characters of the file being open. Let's have a quick review of what we've learned in this lecture. A file is a place on the disk where group of related data is stored. C supports a number of functions that have the ability to perform basic file functions like naming a file, opening a file, reading a file, writing a file, closing a file, defining and opening a file. When we open a file, we must specify what we do with the file. For example, we may want to write data or read data. First statement declares fp as a pointer to the data type file, as stated earlier. File is a structure that is defined in the IO library. Second statement opens the file named file name and assigns an identifier to the file type pointer fp. This pointer contains all the information about the file, is subsequently used as a communication link between the system and the program. The second statement also specifies the purpose of opening a file. A file must be closed as soon as all the operations on it have been completed. The general format is InputOutput Operations on files. Once a file is open, reading out or writing to it is done using the standard IO routines. getC and putC functions. They are analogs to getChar and putChar functions and handle one character at a time. The getW and putW functions. They are very similar to getC and putC functions and are used to read and write integer values. Next, we learned the functions fprintf and fscanf, which are similar to printf and scanf functions. The general format of fprintf function is, while the general format of fscanf is. It is possible that an error might occur in a file during I/O operations. C provides two status inquiry library functions, namely feof and ferror. feof is used to determine if the end of the file stream specified has been reached. The general format is: the ferror function reports the status of the file indicated. It also takes the file pointer as its argument and returns a non-zero integer if an error has been detected to that point during processing. It returns 0 otherwise. At times we are interested in only a particular part of the file and not the entire file. This can be achieved with the help of functions fseek, ftell, and rewind available in the I/O library. ftell takes a file pointer as a parameter and returns a number of type long which corresponds to the current position of the pointer. Rewind takes the file pointer as a parameter and resets the position to the start of the file. fseek function is used to move the file position to a desired location within the file. Command-line arguments is a parameter supplied to the program when the program is invoked. It is possible to pass arguments to C programs when they are executed. The brackets which follow main are used for this purpose. argc refers to the number of arguments passed, and argv is a pointer array which points to each argument which is passed to the main.